Okay, YouTube, in this video we're going to continue our exploration of how we can use sum and difference formulas to evaluate functions for exact values that we don't often know exact values for. And so in this video what we're going to do is we're going to look at a situation in which we are actually given some trig function information and then asked to find, say, the trig function value of a sum or difference of two angles that were involved with these two different trig functions here. And so let's go ahead and take a look at a given situation here, and I'll kind of explain what I mean. So in this particular instance, what we're interested in finding is the cosine of a difference of two angles. And certainly we could take this cosine value. As a matter of fact, why don't we just go ahead and do this right now? And using our sum and difference formula, say that when we rewrite this, I suppose, as an equivalent form, we'd say, well, it'd have to start with cosine because this expression here starts with cosine. And our angles stay in the same order here. So we have cosine A, and cosine is consistent here, so we'd say cosine, cosine, and then we get plus here. Cosine always has an opposite sign here when we rewrite this with sum and difference, but we have a sine, sine, and we still have this A, B arrangement with terms with respect to our angles here, so we say sine B. Okay, squeeze that in there. So we have cosine A, cosine B, plus sine A, sine B. Here's the deal with what we know right now. The fact is that we're being told that the cosine of angle A is equal to -4/5. And so you got to keep in mind that always when we're being told the value of a trig function here, we're already being told, two sides of some right triangle that exists, okay? And so we have the cosine of A is -4/5, and we're being told that, A is some angle between pi and 3 pi halves. So I suppose if pi is here and 3 pi halves is here, instantly we know that this angle has to terminate down in the third quadrant. And likewise, we're being told that the sine of some angle B, okay, is equal to 5/13. So now we know two other parts of a right triangle, and we're being told that this angle B looks like between 0 and pi halves, or 0 and 90 degrees. And so this angle, is just some angle in the first quadrant right here. And so with all of this being said, basically what we would do is start by considering the quadrants in which each of these angles terminates. I'd say, okay, well, this first one terminates up here. I could draw a triangle there, and this last one terminates down here. I could draw a triangle here. But basically, we would instantly sketch a triangle given these values here to represent this situation that terminates in that quadrant and gives us these respective cosine and sine values. And so what you're going to see here is, for instance, this first one here, cosine A. You're going to see that this angle A is our angle terminating in the third quadrant here. And because we were told that the cosine of A is equal to -4/5, and recall that when we find the cosine of an angle, the cosine of some angle here, it's equal to x over r, you'll see that we already know that because r is always positive, 5 is this r value here, and it's got to be the positive part of this negative ratio, and the -4 is just this x part right here. And they did not in this screenshot write a negative there. You could write a negative there if you'd like, but basically what we know is this. We know that -4 over 5 is our adjacent over hypotenuse relationship here. And you could also see that in order to find out that this side was 3, that they've used Pythagoras to figure that out. But basically, here's our angle A, and here's the triangle that represents the situation. With respect to angle B, we knew that it terminated in the first quadrant. We were told this. And so when we sketch this, random angle here, B, in the first quadrant, we know that the sine of this angle is 5/13. And recall that the sine of an angle is y over r. And so with respect to this angle in the first quadrant here that we make a right triangle out of, we know that this is 5, our y value, and our r value is 13. And so again, with Pythagoras here, we could determine that this bottom or base side here must be 12, and this is some 5, 12, 13 triangle. The nice thing about this is that instantly you see up over here that we could figure out some of these values that we didn't know anything for. That is to say that we already know that the cosine of A is -4/5, and we need that when we rewrite it here. And we also know that the sine of B, which is this value right here, we also know that's 5/13, but the two that we weren't aware of, that we needed to figure out, were the cosine of B and the sine of A. And the nice thing about drawing these A and B is that we could actually just go evaluate those. So for instance here, what I want to do is I want to write the cosine of B equals, and I want to write the sine of A equals. And so we'll just go look at our images that we've got sketched for us here. We're going to sketch on our next example on our own, but we'd say this angle B, if we wanted to find the cosine of this, that would be x over r, or adjacent over hypotenuse. So the cosine of B really is just 12/13. And the sine of A, looking over here at A would be opposite over hypotenuse, or if you'd like, we'd say y over r. So we get 3/5, and you'll notice that this 3 must be a negative here, so we get 3/5. And so knowing these now, I'm going to put a box around these, okay? And we knew these initial two right here and here. What I'm going to do is I'm basically going to swap out all of these values here for cosine A, cosine B, and sine A and sine B. We're just going to fill these in. And so we get that the cosine of A is negative 4/5, so negative 4/5. Cosine of B, now cosine of B we were able to find from our sketch here is 12/13. I'm going to kind of scribble that out there. Now the sine of A, we didn't know over here, but we were able to find it from our sketch. Okay, we got negative 3/5, so I'm going to fill in a negative 3/5. And then the sine of B, we did know the sine of B was 5/13 from the given information here. And so what we get when we simplify this is, let's see if anything, cross cancels here. I don't really think that anything does. So we get 5 times 13. The nice thing is we get that on both of these ratios here. So 5 times 13, 50 plus 15 is 65. And we get a negative 48 on top. So negative 48. And then this is going to be plus now. Negative 3 times 5 is negative 15. Negative 15. And this is over another 65 here. So when we add these together, it looks like, let's see, 48 plus 15 would be 58 plus another 5 is 63. We get equals to negative 63/65. And believe it or not, I'm going to put a box around this and I'm going to say that this, you guys, equals the cosine of A minus B. And this is what we're trying to find right here. This must be it because when we used our sum and difference formulas here, okay, we just filled in for the cosine A, cosine B, sine A, sine B using the given information we were given previously. So what we're going to do this time is a little bit different. We're going to say that, yeah, I've been given this information, but I have to go sketch these angles on my own. So our job here is, what I want to go do is find the cosine of A minus B. I'm going to do this again here. As a matter of fact, I'm just going to go ahead and start by just saying this, the cosine of A minus B. It's got to start with a cosine also, and so we'd say, cosine doesn't alternate, so we have cosine A, cosine B. Cosine has an opposite sign here as it does over here, and then we'd say, okay, so this must be sine A, sine B. Okay, so since we're all set now, we just need to find these four things, and I'll tell you what, we already know. I'm going to put this in a different color. We already know the cosine of A, and we already know the sine of B. And so what we're going to say is we just need to go find cosine B and sine of A. And I'll tell you, if you draw these images, it's going to be a piece of cake. So what I know is this. What we're told is this. The cosine of A is negative 12/13, and that our angle exists between pi halves and pi radians. And so we say pi halves up here, pi over here. That means I have some angle over here. And I'm not going to draw this to scale, and I really apologize for that. But basically, what I'm going to do is I'm going to drop my altitude and say, well, what do I know about this angle here? Because this angle A, I'm going to fill this A in right there. We're going to say negative 12/13 when I take the cosine of it. And so the cosine, remember, cosine is x over r. We would get our x value is negative 12, and our r value must be this positive 13. So very quickly here, we're going to say that this is a y value. We have y squared plus negative 12 squared is equal to 13 squared. This means that we have y squared plus 144 is equal to 169. And when we subtract 144 from both sides here, 144 from 169, I believe, gives us a 25, which means that our y value is either a positive or a negative 5. And looking at this sketch up here, it looks like that it must be a positive 5. So I'm going to scratch out the negative here and say y is a 5. And so that being said, that's going to help us here in a minute when we need to go find, say, the sine of angle A. As a matter of fact, we can already write that right now. We say the sine of A, with the sketch I've seen here, would be y over r, opposite over hypotenuse. So the sine of A is 5/13. I'm just going to leave that right there. Boom. So now, let's look at B here. We were told that sine of B is 3 over 5. So we have, y over r here. Is 3 over 5. We have two sides of this right triangle for angle B. And the B terminates in the first quadrant. So I'm going to draw on this angle that terminates in the first quadrant. I'm going to drop down this altitude. And I'm going to say, hey, this is angle B right here. So what we're told is that when we take the sine of B, which is y over r, opposite over hypotenuse, we get 3 over 5. And you know what? This is a 3, 4, 5 triangle, but I just want to show you again here. We have x squared plus 3 squared is equal to 5 squared. We'll just use Pythagoras to get some values out of this. So we have x squared plus 9 is 25. 9 from 25 should leave us with 16, and so our x value is either a plus or minus 4. Looks like it's going to have to be a 4 here when we take the square root of both sides. So I'm going to fill that in. And like I said, we need to know this. We have the sine of A now. We just need to find the cosine of B. And looking at B, the cosine of B would be x over r. We have our x value. We have our r value. I'm going to write that down explicitly here. We have the cosine of B, would be 4 over 5 and be a positive 4 over 5. So now what we have is a situation where we've rewritten this using the sum or difference formula. All we need to do is evaluate. So we have the product of those two trig values plus the product of these two trig values, and we're just going to drop these things in. So the cosine of A, we were told the cosine of A up here is negative 12 over 13. Now the cosine of B we found on our own is 4/5. The sine of A, now the sine of A is 5/13 here, okay, and we have the sine of B right here. The sine of B we were told was a positive 3/5. So again, I want you to see this. We're going to get this situation where, nice, both of these factors on the bottom are the same thing on each of these. So you're going to have a common denominator. It's what's on top that we really care about here. So we get negative 48 65ths in this case. And this would be plus a positive 15 65ths. So in this case, we get 65ths, okay? But when we add these together, because they have different signs, overwhelmingly negative, I would say, on relatively negative. But we would say that 33 here, or negative 33 65ths. And I just want to be clear on this. This would be the cosine of A minus B if what you've told me about these two values is accurate. So that's how we can use the sum and difference formulas to rewrite, and then from a sketch, evaluate using arbitrary angles. Cheers.